I'm Anil Kumar, sharing with you a test problem on Bernoulli's distribution. A random number generator provides a number between 1 and 100 over a total of 6 trials with repetition permitted. Calculate probability distribution for the number of times a prime number is output. You can always pause the video, answer the question, and look into my suggestion. Now, in this case, we are generating numbers randomly, so that is the experiment being performed. In this experiment, if we get a prime number, it will be treated as success. If not a prime number, a failure. So we have two options. Every trial is independent since the numbers can be repeated, right? So we have 6 Bernoulli trials, and this is a candidate for binomial distribution, right? So I hope you understand why binomial distribution is in this particular case, right? Now let's figure out what our random variable should be. So since we need to find number of times a prime number is output, so we'll define our random variable as equals to number of times prime number, right? So it is number of times we get prime number. So that is the random variable. Okay. And n, the number of trials, is 6. What is the probability of success? That is the probability of getting a prime number. Now, how many prime numbers are there? There are actually 25 prime numbers. Let me list them out for you. Right. There are 25 prime numbers. These numbers are beginning with 2, right? So it is 2, 3, 5, 7, 11, 13, then we have 17, and then we have 19, then we have 23, 29, 31, 37, 41, 43, and 50s we have 47 also. 47, 5 and 1 is 6, that can be divided, so we have 53, 59, 61, 67, and then we have 71, then 73, 79, 83, 89, and in 90s we have 97, right? So let's count them. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So we have included all of them. So prime numbers are 25 in all. So out of 125 prime numbers gives us probability of success as 25 over 100, which is 0.25, and that also gives you probability of failure, which is 1 minus 0.25, and that is 0.75, right? So we have all the parameters to work with, and in general the probability will be equals to NC. N is 6 for us in this case, so well, the general formula is NCR, and probability of success and failure. So if there is 0 success, then that is NCR is 0, and Q to the power of n minus r. So that is the general formula for finding the probability, right? So with this information, what we will do now is we'll just create a table of the expected probabilities under this condition, right? So we'll have the values of x. Since there are 6 trials, x could have value as 0, and it could have 1, 2, 3, 4, 5, and 6. I hope you can see this, right? So let me push this a bit. Okay. Now, if there are 0 successes, that means the probability will be what? 0 success means no prime number, right? No number of prime numbers are 0. That's what it means. So in this case, it will be NC0 and P, which is 0.25. Let me write down 0.25 to the power of 0 and then 0.75 to the power of 6. So all 6 are failures, correct? That means not prime numbers. When one of them is a prime number, right, so that one number could be placed in 6 different places. So we get, I should write n, instead of n I should write 6, right? So let me change this to 6. 6C1, 0.25 to the power of 1, 0.75 to the power of 5, correct? So now let's complete this table. 0.25 square, 0.75 to the power of 4, 6C3, 0.25 cube, and then 0.75 cube. The sum is always 6, right? 6C4, 0.25 to the power of 4, 0.75 square, 6C5, 0.25 to the power of 5, 0.75, and 6C6, 0.25 to the power of 6, and 0.75 to the power of 0, right? So we can use the calculator to calculate these values. So let me just input this data here. So we'll start with the bracket just to keep it safe. Okay, so it will be kind of 6C0, 6C0, and then we'll multiply by 0.25 to the power of 0 for the first case, right? Okay, then we'll multiply by 0.75, and first time this will be to the power of 6, okay, and then let's say equals to, I will write the decimal values. We'll just write to 4. We'll truncate the value to 4th decimal place, right? So it is 0.1779. So we're just truncating, we're not rounding, okay? Now let's change this value to find the second probability when we have one prime number out of 6, right? So when we have one prime number, 0.25 to the power of 1 and 0.75 to the power of 5, correct? So that gives you, in decimals, the value is 0.3559, and then we'll do, C2, 0.25 to the power of 2, 0.75 to the power of 4, equals to, in decimals, 0.2966. Let's redo the calculations with 6C3. 0.25 to the power of 3, 0.75 to the power of 3, equals to, in decimals, 0.1318, and now with 4. Okay, 4, 0.25 to the power of 4, 0.75 square, equals to, in decimals, 0.0329, and then again with the 6C5, 0.25 to the power of 5, 0.75 to the power of 1, okay, and that is equals to 4.39, 10 to the power of minus 3, that means 0.0043, okay. The next one is 6C6, 0.25 to the power of 6, and this is to the power of 0, right? And that gives us value equal to 0.0024, right? That is, oh, this is to the power of minus 4, so 0.0024, okay. So let me write this as, okay, I think 0.0002, okay, since that is to the power of -4. So that is the value which you get this time, okay. Now these are the probabilities which we get for all individual values. And when you make a table with all possible values of your random variable and their probabilities, it is called probability distribution table, right? So that is the probability distribution. So we have already done the calculation. So that's it. Now, can you tell me one thing? If I add up all these probabilities, what should that be equal to, right? So if I do sum of all these probabilities, that should be equal to 1, right? So you can just add them up and figure that out. It could be slightly smaller than 1, maybe. We just truncate it anyway, but this to at least 3 decimal places, it will be correct. It will be 1.000 at least, okay? So you can do that exercise. Now that is the way we can do it. We can actually also plot this. So let me show you how to plot this. So what we will do is, I'm just making a rough sketch here, okay? So we have two axes here. Along the horizontal axis will represent the random variable x, and along the vertical axis will represent the probability, right? So that is the number of, these are the number of prime numbers, right? Number of prime numbers. Which could be 0, 1, 2, and 3. Now, when we sketch these graphs, it is kind of important that we have a width of 1 unit, right? So what we will do is we'll make well, I know I've drawn it like this from this side, but we kind of have 1 unit length. So let me just assume these bars which I'm sketching, these bars have a unit width, okay? So I'm just sketching few bars to help me sketch a neater graph. That's the whole idea, right? So 1, 2, 3, 4, 5, and okay, let's say one more. Let me come to this side. Okay, let me come to this side. Okay, 6. So I have these bars representing, so that because I'm making a rough sketch, and the maximum value here is close to 0.4. So let's say this is 0.4 for us. Okay, so 0.4, and then half of this will be 0.2. So these are my rough sketches, and then kind of 0.1 here, okay, and 0.3 somewhere there, okay. Now let us sketch. So what we have here is, so at 0 we have 0.177. So this is 0.1, so we have 0.1, 0.2, 0.3, 0.4, correct? So at 0, so this is at 0, mid value, right? So we have 0.177. So it's kind of close to this. So this is the graph which we have. Is it okay? So that is for random variable 0. Since the area under the graph should be representative of the probability, that's the whole idea, right? So this area gives you this. When I have a unit width, then the height becomes the area. That's the whole idea, right? So it's a very important criteria. Now 0.359, so kind of here, is it okay? So 0.359, so we have here. So we'll get a histogram. So that is the area, which is 0.3559, to get an idea, right? So that is when it is 1. 0.29 is very close to 3, so we'll do this part here. So take care that when you draw these, it's good to have some clarity about what we're trying to do. 0.13 is when it is 3. So 0.13, so kind of like this. Okay. For 3, and then for 4 it is 0.004. So it's kind of just let me say let this be 0.00444, and I mean, did I skip something? For 4 it is 0.03. Okay, so for 4 it is slightly higher, 0.03. So this is 0.5. So maybe here. Okay, that is for 4. And for 5 it is 0.004. So it is, let me just show it by this method. This is for 5, and for 6 it is even lower. So it is kind of like, is that okay? So this is for 6. So that is how we'll get our histogram, right? So where these are my points, which represents the probability for each. Do you get it? So that is what it is. Is it okay? So this is my probability distribution for the given condition, right? So the number of prime numbers could be from 0 to 6. These are their probabilities, and that is how you could actually sketch. I hope that helps you to understand the concept. I'm Anil Kumar. You can always share and subscribe my videos. Thank you, and all the best.